All right, 8.1, sequences and series. We're going to be using sigma notation. So sigma, this is the Greek letter sigma. That's the lowercase sigma, that's the uppercase sigma. Just like the 8th letter in the Greek alphabet, H lowercase and H uppercase look different. Little small h, capital H look different. Same thing in Greek. That's a lowercase sigma, there's an uppercase sigma. In math, both these symbols are used in math. That's used in standard deviation. We're not doing that yet. Standard deviation, we'll do that later. This is used for summation notation. Summation notation. So it's the capital letter sigma, and that's what we're going to be using here. So when you see this capital letter sigma, that means we're going to be using summation notation. So this is summation notation. We're going to add a bunch of numbers up. Okay. The number down here, this is the lower limit. This is going to be the upper limit, and that's going to be your formula in that spot right there. So when you see something like this, what the heck does that mean? What? So it means we're going to start at 1 and go up to 6. The lower limit's 1, it goes up to 6. There's 6 terms in the sequence. When it starts at 1, this is so much easier. There's 6 terms. Hey, 1, 2, 3, 4, 5, and 6. You have to add them up. 1 n is 1. 2 times 1 is 2. 2 times 2 is 4. 3 times 2 is 6. 8, 10, 12. Boom. And now the summation means we have to add them up. It's going to be a series. So that right there was 14. That's 14. That's 14. So 14 times 3, 42. 42, bada bing, bada bang, bada boom. Okay? So it starts at 1, goes up to 6. There's 6 terms in the sequence. That's your formula. The lower limit's 1, upper limit's 6. In this case, here's the formula. I is from 1 to 5. There's 5 terms in the sequence. It's so much easier when you start with 1. So much. Okay, 5 terms. 1, from 1 to 5. 2, 3, 4, 5, and then we have to add them up. When I is 1, that's 1. 1 plus 1 is 2. Divided by 2, that's 2. That's a 1. When it's 2, we got a 2. 2 plus 1 is 3. For 2, that's a 3. When I is 3, 3 plus 1 is 4. 2 is 6. When I is 4. Got 4. 4 plus 1 is 5. Divided by 2, 10. And I is 5. So 5. 5 plus 1 is 6. Divided by 2, 315. Then we add them up. So that's going to be 4, 10, 20, 35. 35. Done. Next one. Sigma notation. So there's 7 terms in this seq. Oh no, don't get stuck on that trap. Most people do that. That's not a 1. If that was a 1, there would be 7 terms. There's not. It starts at 3, goes up to 7. 3, 4, 5, 6, 7. Okay. Starts at 3. The lower limit's 3, upper limit's 7. Start at 3, go up to 7. Stop. Okay. K squared minus 1. So 3 squared is 9, minus 1 is 8. 4 squared is 16, minus 1 is 15. 5 squared is 25, minus 1, 24. 6 squared, 36, minus 1 is 35. 7 squared is 49, minus 1 is 48. Then you, summation notation, we add these together. Man, what the heck is this? Good thing if you have a calculator, it makes this stuff easier to work with. 8 plus 15. 8 plus 15 plus 24 plus 35 plus 48. 130. 130. 30. So this stuff, once you get the hang of this stuff is pretty straightforward. You just have to follow the rules. That's the lower limit, it's the upper limit, here's your formula. And just follow that. Okay. So these are the sequence. We have arithmetic sequences, geometric sequences. We've talked about those. There's in our class, we're just using arithmetic and geometric sequences. There's two more. There's harmonic sequences, Fibonacci sequence. Harmonic sequences, if you study music, they study harmonics. We're not studying music, so we're not covering harmonics in this chapter. We're not covering Fibonacci sequence in this chapter. Fibonacci is a lot of patterns in nature that has a Fibonacci sequence. But this chapter that we're covering in this book is concerned with arithmetic sequences and geometric sequences. And there's something you do need to know when you see something like this. When you see something, this one's going up by 3 units, up by 5, up by 7, up by 9 units. When you see something like that, going up by 3, up by 5, up by 7, up by 9, likely it's going to be that pattern right there. This comes into play. I think this was either question 25, 26 on page 414. That helped you on either 25 or 26. In this case, n cubed, 1 cubed is 1, 2 cubed is 8, 3 to the third power is 27, 4 to the third power is 64, 5 to the third power is 125. This pattern is used, I don't know if it was 25 or 26 on page 414, but that's where it's used. Okay. So next we have, before we started with sigma notation, and we got these numbers. Now we're starting with these numbers, and you have to work backwards. And hey, write this series. This is series because we're adding. Write this in sigma notation. What? Okay, what's the difference here? We're adding. It's adding 3, adding 5, adding 7, adding 9. What the heck? Adding 3, adding 5, adding 7, adding 9. How in the heck are we supposed to do something like that, Mr. Top? You never, ever told us about that. Never, ever, ever, ever told us about that. Good thing you can rewind the video. Looks like it's going to have n squared in there somewhere. Let's try n squared. So if that's our first term, it starts here, it ends there. No más. No hay más. First term is 5. The second term is 8. The third term has a value of 13. The fourth term has a value of 20. The fifth term has a value of 29. So sigma notation, we're going to use the letter n. And we're going to start at 1. And 1, 2, 3, 4, 5. Go up to 5. From 1 to 5, there's 5 terms. So n squared. 1 squared is 1. We want to get to 5. I wonder if it's 4. Let's see if that works. 2 squared is 4, and if you add 4, you get 8. Nice. 3 squared is 9. If you add 4, you get 13. 4 squared is 16 plus 4. There we go. There's our answer right there. Bing, 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 boom. So it's the capital letter sigma. I'm using the letter n. N equals 1. This is the lower limit. The upper limit is 5. And this is our formula. Make sure you put parentheses around that. There you go. Next one. This is 33b, by the way. So it's similar to 33. Not the same, but it's similar. 34. This is question 34. So negative 1 plus 2 plus 7 plus 14 plus dot. This is ellipses, which means this goes on forever. First term is a value of negative 1, second term is a value of 2, third term is a value of 7, fourth term is a value of 14, and dot. It keeps going. So we're adding 3, adding 5, adding 7. I wonder where you use something like this. Oh, yeah, it's probably going to be that squared term. Again. Start with 1, and it always start with 1. It makes you, the reason why I want my students to start with 1, if everyone starts with 1, that means if you're correct, everyone has the exact same answer. I don't care what letter you use. I personally would not use the letter S. I would not use the letter O. I personally would not use, I don't think I was a wise choice on my part because the letter I looks like a 1. I can be confused that way. X, I would not use the letter X. Use the letter N a lot, K. So when N is 1, ooh, so we're adding 3, adding 5, adding 7, so N squared. So this is dot, dot, dot. So this is just going to goes up forever. So this is infinity. Take the number 8, lie it on the side. That's the symbol for infinity. So number 8, lying down. Okay, that's the symbol for infinity. So it's going from 1 to infinity. So the first one, N is 1. N squared is 1. We want to end up at, what if we subtract 2? Is that going to work? N squared minus 2. N squared minus 2. Is that going to work? 2, when N is 2, 2 squared is 4. 4 minus 2 is 2. Ooh, looks like it works so far. Oh, bloody nose, dang it. Three squared is 9, minus 2 is, oh, there you go, minus 2. Sweet, boom. This is your answer, boom. Those 3 dots means it goes on forever. When you see those 3 dots, that's always going to be infinity. When you see these 3 dots, that's always going to be infinity, the upper limit. Okay. Question 35b. 35b. 2. Oh my God. Ugh. So your fractions, let's do one part at a time. Let's just do the top. So it's just 2, 2, 2, 2. Oh, this is going to be kind of straightforward. The top number looks like it's just going to be a 2. Straightforward. The numerator, always a 2. The bottom number, we're going adding 6, adding 21, adding, ooh, that doesn't work. 3 times 3 is 9, times 3 is 27, times 3, times 3, times, we're not adding 3, we're multiplying by 3. So it's 3 to the power of n, or 3 to the power of n minus something, or 3 to the power of n plus something. Okay. It's gonna be one of those. I don't know which one is one of them. Okay. So the first term has a value of 2/3. Second term has a value of 2/9. Third term has a value of 2/27. Fourth term has a value of 2/81. All right. So let's start with, I'm going to use the letter N. And we'll start with 1. We are always going to start with 1. Since it's dot, 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 we're going to have infinity right here. So 3n. So let's try this. When n is 1, I'm going to try this. 3 to the first power is 3. We have a 3 there. Oh. 3 to the second power is 9. 3 to the third power is, looks like it's just 3 to the n. We don't have to use a minus or a plus. Oh, it looks like that one. Oh, sweet. Looks like it. So let's try this. When n is 1, we get 2, 3, 2/3. When n is 2, 3 squared, 9, 2/9. When n is 3, 2/27. There we go. That works. Bada bing, bada bang, bada boom. Okay. Remember, when you're alternating, when the numbers are alternating from positive to negative to positive to negative to positive to negative, here's the case right here, number 37. It's alternating positive to negative, positive. You're going to, first term, second term, third term, fourth term, fifth term. It's alternating from positive to negative. You're going to have a -1 to the nth power, or -1 to the n plus 1. This one starts out with a negative, negative, positive, negative, positive. this one starts off with a positive number, then a negative, then a positive, then a negative, then a positive. Okay, so when n is 1, negative 1 to the first power is a negative. So this one we're going to have a negative 1 to the nth power. So we're going to start. That takes care of the alternating positive, negative, positive, negative, positive, negative. Okay? So now I'm just looking at right now, in my mind, I'm just thinking of this. 3, 4, 5, 6, 7. I don't care about the positive or negative right now because this took care of that. So we're adding 1, adding 1, adding 1, adding 1. So it looks like it's just n, or it's n plus something, or n minus something. Man, I just can't make my question marks very well. So we want to start with 1 and we end up at 3. Start at 2, end up at 4. Start at 3, end up at 5. It looks like we're adding 2. N plus 2. N plus 2. N plus, there we go. N plus 2. So the nth term is going to be this. See if that works. 2, positive 4. Yep. What about this? When n is 3, it's going to be negative 3 plus 5, negative 5. Nice. That was just boom, 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 boom. There you go. Beautiful. Sigma notation. Just remember, sigma notation. Sigma notation, that's the capital letter sigma, means summation notation. This is the lowercase sigma, that's standard deviation, that's something down the road. Okay. Good luck, guys. Hasta la bye-byes. Hold on, let me wait 4 seconds till it gets 17 minutes. And boom, there we go.